Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the entropy equation. For an open system as shown in Figure 3.3, the entropy equation can be introduced based on the entropy balance. As mass and energy are accounted for by mass and energy balance respectively, entropy is accounted for by an entropy balance. Unlike mass and energy, which are conserved, entropy is produced within system whenever non-idealities, such as friction, are present. The entropy balance for an open system is the sum of the entropy flow into the thermal system minus the sum of the entropy flowing from the thermal system plus entropy generation of thermal system equals total entropy increment of the thermal system. Then the entropy change for the system can be expressed as integration the entropy balance for a period of time. We have the entropy equation. The entropy equation shows that the entropy change of the thermal system is equal to the sum of the total entropy flow and entropy generation. For a closed system, there is no mass exchange between the thermal system and the surrounding. The entropy equation becomes: for a closed adiabatic system, there are no mass and no heat exchanges between the thermal system and the surrounding. The entropy equation becomes: for an isolated system, the entropy equation becomes. This is the increase of entropy principle for an isolated system, and this is the method 1 statement of the second law of thermodynamics. Entropy is an extensive property. Thus, the total entropy of a system is equal to the sum of the entropies of the parts of the system. An isolated system may consist of any number of subsystems. The entropy change of an isolated system is the sum of the entropy changes of its components and is never less than 0. A system and its surroundings, for example, constitute an isolated system since both can be enclosed by a sufficiently large arbitrary boundary across which there is no heat, work, or mass transfer. Therefore, a system and its surroundings can be viewed as the two subsystems of an isolated system, and the entropy change of this isolated system during a process is the sum of the entropy changes of the system and its surroundings, which is equal to the entropy generation, since an isolated system involves no entropy transfer. The topic of this subtask is about some remarks about entropy. We should be clear: the entropy change of a system can be negative, but the entropy generation cannot be negative. Process can occur in a certain direction only, not in any direction. A process must proceed in the direction that complies with the increase of entropy principle. A process that violates this principle is impossible. Entropy is a non-conserved property, and there is no such thing as the conservation of entropy principle. Entropy is conserved during the idealized reversible process only, and increases during all actual process. The performance of engineering systems is degraded by the presence of irreversibilities, and entropy generation is a measure of the magnitudes of the irreversibilities during that process. It is also used to establish criteria for the performance of engineering devices. Okay, that's all for this task. Thank you very much, and see you next time.